Hi, my name is Stephanie Davidson, and I'm an assistant professor at Ryerson University in Toronto, Ontario, Canada. This presentation documents in-progress design research in temporary biodegradable thin shell structures. The shells have been cast using a variety of cellulose-based materials and represent a sampling of the outcome of a studio taught at 3 different architecture schools to date at the graduate level. The most recent research focused on increasing the size of the thin shell cast paper structures to full scale. Full scale here means a size where 2 or 3 people can sit or stand inside. And in the most recent set of experiments, the focus turned to scaling up. By focusing on size, a new set of questions emerged. How can a formwork system be developed that doesn't defeat the ambition of creating a temporary thin shell with a light footprint? Can form finding in formwork still be one and the same? And whereas in previous projects, the traditional paper-making tool of the mold and decal were used to fabricate the cast paper shells, many of these scaled-up structures used a spraying technique. Is the traditional paper-making process using a mold and decal relevant for full-scale cast paper structures? The fact that pulp, wood, or cotton is cast into paper is common knowledge. Even casting paper into monocoque structures at small scale is something we can see in our daily lives in the form of egg cartons or biodegradable fiber pots for seedlings, as shown in these photos. The mechanical interlock achieved with cellulose fibers when cast appears quite forgiving. Various fibers can be combined and cast into sheets or three-dimensional forms without a high degree of technical skill or precision and without the need for industrial scale equipment or expensive tools. I'll now show a selection of 5 projects done over the past 3 years at different universities. Through the projects, I'd like to show and compare the variable success of the broad range of cellulose-based materials used to date. 3 projects that used a mold and decal to fabricate full-scale cast paper structures were constructed using animal bedding, toilet paper, and cotton linters. 2 projects that used a texture sprayer to fabricate full-scale shells were constructed using recycled printer paper and craft paper. A mold and decal is a low-tech tool used to cast handmade paper. To familiarize themselves with the process of making pulp and casting paper sheets, all students made a mold and decal to cast test swatches using various cellulose fibers at the beginning of each semester. Molds in this case were wooden frames with dimensions around the size of a piece of US letter paper covered with nylon mesh. The first project I'm showing sought to make a 2-meter diameter sphere out of thin cast paper membrane. Toilet paper was used exclusively for this project with no additives. Toilet paper can be composed of recycled wood pulp or cotton fibers depending on the brand. It's very easy to make toilet paper pulp. The recycled fibers break up instantly when soaked in water. Formwork in this case was an oversized balloon. Pneumatic formwork suits cast paper structures well because they can be removed easily without stressing the thin shell. The team of 2 students worked in tandem with a mold and decal. The distribution of the cast toilet paper sheets over the pneumatic formwork was time sensitive, as mechanical interlock of the fibers can only be achieved with 2 or more sheets that have a similar moisture content. This project used animal bedding, another low-grade recycled paper fiber product. Like toilet paper, the animal bedding broke down and suspended evenly in water. It was very conducive to making pulp for paper casting. Potential additives, which were not listed on the packaging for this product, made the fiber thicker and stiffer than when cast compared to toilet paper. The approach to the formwork in this case was more strategic than designed. The students looked for spatial conditions in the architecture building's interior that would impart structural form to the aggregate of cast paper sheets. Paper was cast against corner conditions to achieve a corrugated plane. Stairs and the floor-to-wall connection were cast in order to obtain a rigid 3-dimensional plane. This project used a combination of 3 cellulose-based fibers to cast a catenary dome using a formwork constructed with a lightweight wood frame and hanging cotton string. Cheesecloth was suspended in the interior of the hanging string formwork in order to provide a planar surface onto which the student cast circular pieces of cotton paper. The main body of the shell was cast using cotton linters, and at the bottom of the dome, the student reinforced the rim, which he anticipated would be vulnerable to tearing, with crushed peanut shells. To create a uniform and fast covering of a surface with paper pulp, a texture sprayer, also known as a texture hopper gun, was used for several student projects. The texture sprayer used in these projects was a standard tool typically used to create textured drywall finishes on building interiors. In this project, students sourced printer paper from the recycling bins at the university library. Since printer paper is generally recycled and consists of wood fibers, which are shorter than cotton fibers, when shredded and soaked, this paper blended relatively easily into pulp. The pulp was fine enough to spray with a hopper gun. Pneumatic aggregate formwork was used to define the geometry of the cast shell and to support the several layers of pulp that were sprayed. Hundreds of balloons tied into clusters of 3 were assembled into a volume and bound to the floor with netting. Formally, the shell is characterized by an all-over surface deformation in the shapes of the balloons, which make up the formwork. The small-scale surface deformation acts as a double-curved corrugation and stiffens the shell considerably. This final project was fabricated using an integrated armature and craft paper pulp sprayed using the hopper gun. This shell is the largest in the selection of projects documented in this presentation. The height of the shell was 3 meters. Formwork was sewn out of burlap and pulled into tension using cords. And when sprayed with craft paper pulp, the shell became rigid. Once the paper shell was fully dry and rigid, tension connections were cut, inverting all tension into compression parallel to the shell surface. In conclusion, casting paper is a relatively unexplored method to creating large-scale thin shell structures. Because paper is so vulnerable to moisture if left untreated, its use in outdoor applications is either climate-specific or deliberately temporary. But paper's vulnerability to moisture can also be seen as an asset, since structures made with paper have the capacity to biodegrade in a short amount of time with no adverse impact on the soil or surroundings into which they disintegrate. This line of research in material and fabrication asks us to shift our attitudes towards strength and longevity in structural design. Thank you.